Okay, let's look at question 2 of the physics paper. So it says a 20 kilogram block is placed on a rough surface inclined at 30 degrees, okay, to the horizontal. A constant force F acting parallel to the surface is applied on the block so that the block moves upwards up the incline at a constant velocity of 2 meters per second. Refer to the diagram below. Then it says a constant kinetic friction force of 18 newtons acts on the block. Okay, so question 2.1 says state Newton's first law in words. Okay, so this definition, you guys can go and look up your definitions. I'm not going to focus on definitions. I would rather want to focus on the calculations and the drawings. Okay, so 2.2 says draw and label a free body diagram. Okay, so free body diagrams are always represented as just a single point. We're taking the object and we're converting it to a point. Okay, so you can either break everything into components or you can draw it as is. Okay, I like drawing it as is, or that's up to you. Okay, so if you are worried that you might forget about components doing calculations, then draw it as components. Otherwise, just draw it as is. Okay, so we're going to have our weight, or the force due to gravity, always acts straight down. Okay, so my weight is always straight down. Then we're going to have the applied force, which sits at the angle which is parallel to the slope. This is F applied. Okay, then we're going to have our normal force. Our normal force always sits perpendicular to the surface. Okay, normal force is always whenever an object is on a surface. And then what we're going to do is we're going to have this frictional force. Okay, and those are the only forces acting on this object. If you want, you can break up the frictional force into your parallel and perpendicular force. Okay, you can draw it that way if you want. Okay, now all that's left is to draw your key. So F applied equals to your applied force. Okay, then Fn is your normal force. Okay, and then W is weight. Okay, remember weight is a force. And then F of frictional, kinetic friction, as they've stated, is then your frictional force. Okay, so total of 4 forces. Okay, alright, so now let's see. 2.3 says calculate the magnitude of the force applied. Okay, so dealing with Newton's law here, so therefore we're going to use F net equals to ma. Okay, now because it says it's got constant velocity, okay, nb acceleration equals 0. Okay, so therefore we are going to sum up all our forces. Okay, so I'm just going to draw the picture over here quickly. We've got the block here, we've got force over there, and then everything else acting on it. I'm going to take up the slope as positive, down the slope as negative, meaning up positive, down as negative. Okay, so weight can break up, the weight component is going to break up into its perpendicular and horizontal. Okay, so what we're going to do is we're just going to add up all the forces acting along the slope. Okay, so that's going to be force applied. Okay, then we're going to plus, now the friction is acting downwards, and that's 18, so we're going to have minus 18. Remember, the negative indicates direction. Okay, plus minus now the parallel component of weight, so that's going to be 20 kilograms times 9.8. okay, and then because we're moving down the slope, it's sine of 30 degrees. Okay, and that's all going to equal to my mass, okay, which is 20, but because we're moving at constant acceleration, constant velocity, my acceleration is 0. Okay, now all that you need to do is plug into your calculator. So you'll have this one minusing off that one. Okay, so if you take it to that side, it becomes positive, so therefore your F applied, okay, once worked that out, is going to give you 116 newtons. Note that the answer is positive, therefore it's up the slope. Okay, so I don't have to indicate that. Alright, the next one says then it says force F is removed when the block reaches point X, okay, on the surface. The block continues to move up the surface and comes to rest at point Y. Assume that the kinetic frictional force acting on the block remains 80 newtons as it moves from X to Y. Okay, so 2.4 says now write down the net force acting on the block as it moves from X to Y. Okay, now the net force could also be the sum of all my forces, okay, but we can just use F net equals ma. Why? Because you're moving at constant velocity, therefore acceleration is 0. So now all that's happening is we removing, okay, my applied force. So that's all it says. Force F is removed when the block reaches the point. Okay, so we saw that force applied equals 116 newtons. Okay, now because it's moving up at a constant acceleration, constant velocity, not constant acceleration. Because v is constant, a equals to 0. So technically my net force needs to equal to 0, meaning whatever's pulling down the slope must equal to whatever's pulling up the slope. So if I take away the applied force, okay, I'm then just left with the force moving down the slope. Therefore F net is just equal to 160 newtons if I remove the applied force. Okay, why? Because the applied force is technically equal, F applied equals to F friction plus the weight component that is parallel. Why? Because acceleration is 0, therefore your net force needs to be 0. That allows this to happen. So if I take this away, okay, therefore F net is just equal to frictional force plus your weight perpendicular or parallel. Okay, all right. So now if we look at 2.5, it says calculate the distance between point X and Y. So we have the net force acting between that point now that F applied has been removed. So we can actually calculate its acceleration because it's no longer, the net force is no longer equal to 0. So the block's going to slow down. So we're going to calculate the acceleration first. So F net equals to mass times acceleration. Our net force is what we got over there. So we can have 116 newtons equals to 20 times my acceleration. Okay. And then our acceleration is then going to equal to, let's have a look here, 5.8 meters per second squared. Okay, that's going to be, I've made a mistake. Your net force is now negative. Why? Because everything's acting down the slope. Remember I said down the slope, and that should be negative. So therefore your net force needs to be negative. Therefore your acceleration needs to be negative. Why? Because the object is slowing down. Now that we have the negative acceleration, we can calculate the displacement. Okay, but just because we're using Newton's laws doesn't mean we get to forget about equations of motion. Okay, and the simplest one to use is v final squared equals v initial squared plus 2a delta x. Okay, now we just plug everything in. Final velocity 0, initial velocity 2 meters per second squared, okay, plus 2 times negative 5.8 meters per second, negative 2, okay, and delta x. So if you then substitute and you manipulate and solve, you then get delta x to equal to 0.34 meters. Okay, and that's how we go about doing this question. Okay, if you found this video helpful for Newton's law, then please consider checking out some of my other videos. If you have any questions, leave them down in the comment section below and I'll get back to them as soon as I can. If you're enjoying the content as well, then please leave a thumbs up on the video. It does help me out a lot. And please consider subscribing if you do enjoy the videos. And remember, it's never too late to have an OIC moment.